Well, good morning, folks. How are we doing today? Looks like people are starting to tune in, which is fantastic. We are a couple of minutes before 11, so I'm not actually going to start any content until 11 o'clock. However, it's a chance for people to say hi, and if you have any questions about the midterm tomorrow night, do feel free to ask them. Or about anything else. While people are doing that, are thinking about the questions you're going to ask, I am going to pop up a question which will, let's see, there we go. So I'm going to present a question for you which will take a little bit longer than some of our typical questions do. So in the meantime, it's very nice to see people saying hello in the chat and lots of happy Valentine's Days being wished to everyone, so that's lovely. You may have noticed that I am not in my office, not in my usual place. So the good news is the PCR test was negative, so it's fantastic. However, given that I still had symptoms of something or other yesterday, I should probably not be at the office today, as per the guidance we're all receiving these days. So do go ahead and get started on that top hat question, and this is something where you may find it may be tricky to do that by hand, to add up the first 100 squares of integers, or actually I probably should have said whole numbers like I did in the last one, shouldn't I? But this is something that one would be able to write a little Python script for. And hopefully our experience doing that means that you get to do it now. Am I right in thinking that lots of folks are tuning in from home today as opposed to campus? Boy, the chat is really quiet today. I mean, granted, it's not quite 11 yet, but still. Now some people are starting to say things, so that's good. Okay, and I do see answers that are coming in as well, so that's fantastic. Yeah, I'm surprised there are no questions about the midterm. Well, I mean, maybe that's a good sign. Maybe that means that everybody is all set, ready to go. So once again, if you go to the course website, resources, midterm exams, there is some important information there about where you will be writing the midterm. So it depends on the first letter of your surname. And today, we'll talk about how we can extract the first letter of your surname using Python, actually. So that should be lots of fun. And also some material about preparation. And hopefully, everyone had, and I was a little more specific in the course website. I added that update last week. A little more specific about where we went up to in terms of the material we're going to cover. So what we're talking about today is not stuff that you have to know for the midterm. That said, I mean, the stuff we'll talk about today you may find that it helps you with a question or two on the midterm. It helps you to do something more efficiently or something, in which case, that's great. You can do that. But you are not required to know anything from today for the midterm. So someone says, how's your morning going this snowy winter day, sir? Oh, not too bad, not too bad. I don't have COVID, so that's always a good day for those who are just joining. I had to have a PCR test, but it was negative, so that's nice. But I did have something, so whatever it was that I did have is keeping me away from campus today. But I hope to be back on campus again tomorrow so that I can be around for the midterm tomorrow night. Okay, so let's see, where can we find the answers to the practice questions on the practice midterm? So we talked a bit about that on Friday in more detail, but for now I'll just say I don't have any particular solutions, but there are good reasons for that. So if you go back and watch the Friday lecture, you'll see some of the rationale for that. Yeah, lots more good mornings and good morning on Valentine's Day to everybody, and hearts and all that kind of stuff. What is the format of the exam? The format of the exam is going to be on paper. So you're going to bring pencils and or pens, and you're going to write things on paper. And part of the rationale for why we do that in a programming midterm is you don't want the Python interpreter grading your work. You want me grading your work because, well, I'm a lot more generous with partial credit, as some folks will have been discovering with things like assignments. Speaking of assignments, I should also mention that for assignment 1, I added a little bit more detail to the page because apparently I had neglected to add this to the sort of specification of what your assignment is supposed to do. So I was expecting a very specific prompt, and so I should have said so. So for those who were confused by, I gave a prompt, why is it not the right prompt? I'm sorry for that. I meant to put that level of detail in, but apparently I didn't. So I think what actually happened was that originally I wasn't even going to specify what the prompt had to be, but then I thought actually it'll make the auto-grading results a lot clearer, give you much clearer feedback if I do, so I changed the auto-grader, but then I didn't update the website. So originally I wasn't going to have that more detail, then I said I should have more detail, but I only put it in the auto-grader. I didn't put it in the website. Now it's in both, so hopefully that is helpful. And don't forget that that is due on Wednesday. And of course, if you do it before Wednesday, well, it's probably going to be really good practice for the kinds of things that I might ask you to do on a midterm. I won't ask you to do anything as complex as an assignment on a midterm, but thinking about the same kinds of things, how do we design iterative algorithms that use loops and stuff, that's really good stuff for prepping. Let's see, do you want us to resubmit if we already have? So if you submitted and you have, then the auto grader gave you a grade that you're happy with, then that's good. You don't have to resubmit. I just added more detail to the course website about what the auto grader was asking for. Yeah. Oh, okay. So someone says, I mean, like the question, should we be expected to be similar to the practice? Yeah, similar is probably a reasonable way to think of it. I mean, every year we get a different number of lectures in before the first midterm. Often it has a lot to do with snow. Every year we teach things in slightly different orders, and so no previous midterm is exactly like what you're going to see, but yeah, it's a reasonable idea of what a first midterm in this course can look like. All right, so those are some really good questions, and in the meantime, people have been answering my question in Top Hat. That's great, so I'm going to go ahead and close that one now and take a look at the responses. Yeah, okay, so we've got, almost everybody had the right answer, and I hope that for those who gave the right answer, it wasn't done by adding up 1 plus 4 plus 9 plus 16 by hand. Hopefully it was, in fact. I mean, you might have been able to do that with a calculator in that amount of time, but hopefully people were actually playing with writing a little script. And that is an example of how we can do problem solving, the sorts of things we could do by hand for a few examples. Sometimes it's helpful to have a computer if we're going to do lots and lots of examples of something. Okay, so that's good. So let us now get on to some new material. So we're going to talk about slicing and dicing. We're going to talk about slices and indices for iterable things in Python. All right. So remember, last time we were talking about iteration, where we can iterate through something iterable, where that something is a string, or it's a range of integers, or it's a list of values. And those are things that we know how to construct now. We know how to create a string, the string literal. We know, or in fact, a string expression. You can have expressions that involve like strings, a string plus another string. That's another way to get a string. So we can iterate through strings, which we know how to create. We can iterate through ranges, which we now know how to create. And we can iterate through lists, which we now know how to create. And the syntax for a list is opening bracket, comma separated list of expressions, and then a closing bracket, where bracket is of course square. So what is the same about all of these examples? Oh, someone asked, what was the code used to get the sum? So last time we worked through the problem of how to create or how to sum up a certain number of squares. And so if you missed that on Friday, I would go back and take a look at that video where we constructed that example. Right, so what's common with all these examples is we have a for loop, and what's common about the for loop is for all of these things, for each thing in a bunch of things. So this expression here a bunch of things, which can be just a literal value or can be something more complex, for each thing in a bunch of things. So we indicate which thing we want to iterate through, and then we say that contains a bunch of things, and then the for loop iterates over each element within that bunch of things and within that sequence of things. So each thing is one element of bunch of things, and each thing can be named whatever you like. So if we have a bunch of integers that are increasing from 0 up to some number, so if I say that we have, for example, 65 computers in CSF 2112, and I want to call them computer 0, computer 1, computer 2, it would be a pretty common conventional thing to say for I in range up to 66 if I want it to go all the way to 65 if I want to go from computer 0 to computer 64. Why do we often count from 0? Well, we'll see that in just a moment. And so that's what we've seen so far about iteration. And today we're going to see that there are more things that we can do on things that are iterable, on things like strings and lists, etc. We can look at portions of those bunches of things by slicing them, so kind of cutting them in half, or looking at, if this is a big list of things, we want to look at all of the elements from here to here or do something with them, as well as we can do other kinds of operations on these things like reverse them and sort them and things like that. Okay, so in mathematics, so you all have a nice mathematical background, so if I gave you a sequence like this, I said capital X is equal to 0, pi over 2, pi, 3 pi over 2, and maybe I could even have comma dot dot dot, but in this case I'm saying it's a sequence that contains 4 elements. Why don't you tell me, and I will ask it here, why don't you tell me what is x of 2, x subscript 2? What is that value? Boy, we're really quiet this morning. Is that because everybody is tired from watching sports ball last night? I'm told that the halftime show was specifically designed to pander to my age bracket, and that all the people in my age bracket said, "Oh wow, it's really nice to see something that instead of appealing to old people like the Rolling Stones or Paul McCartney or The Who, now they're appealing to young people like me." Oh, wait a minute. Huh. Which is causing some of us to question some things about ourselves. Okay, someone said degrees or radians. So these are numbers. There's no indication here that we're talking about angles. Someone says, I also like sports ball. Someone says it was a great game. Okay, that's good. I'm glad to know. All right, we've got some answers coming in. Not a huge number. Oh, there we go. Someone found the football emoji reaction. There we are. Yes. All right, I'm going to close this question out in just a minute. So let's close this in 5, 4, 3, 2, 1, and close it. All right, and let's take a look at the responses. Okay, interesting. So we had the plurality. It looks like we had people choosing pi over 2, and then we had some people who said pi, and then some people who said other things, perhaps typing things by accident. The correct answer here is, the 11 have it. Why is that the correct answer? So, when we think about a sequence, if I were to show you like a summation sign or something, and I said from I equals something up to something, what is the lowest value that I could start at? So typically in mathematics and in programming, I've already hinted at this today as well as in previous lectures, typically in mathematics and in programming we start counting from 0, which means that in this case x of 0 is 0, x of 1 is pi over 2, and x of 2 is pi. So the correct answer in this case was actually pi, not pi over 2. So we do this in mathematics, and yeah, someone's got in the chat there that I equals 0. Yeah, that's a very, very common thing, right? The summation from I equals 0 up to n of something, right? So we count from 0 in most cases. And that is partly because of the mathematical history and heritage. It is also partly a convention that has been inherited from other programming languages, in which the way that you refer to a bunch of things in memory is by talking about their address in memory and saying at this location plus some offset, where that offset could be 1 or 2 or 3 or 0. So the first element would be element 0. And it's also, as I said, partly because of the mathematical heritage. So we always count from 0. And actually, you'll notice that I think we had an exercise 0 at the beginning of the course even. So that's what we do in math, and we can do the same thing in Python. So what is that thing that we have there called I? What is that called in mathematics? Oh, bother, I shouldn't have showed the next line. That kind of gave away the game, isn't it? Yeah, well, fine. That is an index. So we can index in a sequence by referring to this or that or some other element within a sequence. And the same is true in programming languages. So if we talk about lists or strings or other things, we can index within them, which means that if I have a list that contains a bunch of elements, and in this case I said let's have a list, let's have a variable called capital X, and it holds a list, and that list has the values 0, pi over 2, pi, and 3 times pi over 2 in it. So that programming list looks an awful lot like that mathematical sequence. Then I can also look inside of that list and find specific elements using the square brackets operator, the indexing operator. So if I want to refer to x of 2, well, then I do what's written right here, x of 2. So some important things to note about these indices. First of all, indices, we start counting from 0, as I mentioned. And also, these indices will give us an error if we try to access something out of range. So if I, let's see, what was the score of the game last night? Or maybe I shouldn't ask because somebody's like recorded and they want to watch it after the fact. But oh well, I'm going to ask anyway. What was the score? 23-20. Okay. So let's say that we want to store the scores for both teams in a list. So those scores, how do we write a list? Actually, let's do this in the interpreter. Oh, someone says pain. Okay, yeah, so square bracket, and in this case 23, and then the other score was 20, close bracket, so now we have a variable called scores. So if I want to access one of those scores, I can use the square bracket operator to look at element 0, and that says that element 0 within that list of integers is the integer 23, element 1 is 20. So if I say this, dear Python, what is that? What answer is it going to give me? Right, it's going to tell me list. If I say that, what's it going to give me? Yeah, now this is going to give us int. Very good. If I try to say this, what is the type of scores 2? What am I going to get? What will we see? Yeah, we're going to see some kind of an error, right? So, and it's not because I tried to use past that value to type. It is going to give me an error whenever I try to access an element that is out of range. So scores 2, that's not going to work. And what happens is we get a thing called an index error because our index was invalid. So what's going to happen when I try to look at scores -1? All right, I see lots of error in the chat. And you might well think so. But, surprise. Huh? What's going on there? So, Python indices can actually be negative. So what in the world could it possibly mean to have a negative index? So let's think about something that involves a little bit more values. So let's see, when were the touchdowns scored in the sports ball last night? Somebody give me like a rough guess, and I don't actually care if it's the right number, but tell me approximately when the touchdowns were scored, like by minutes. Okay, so at the 5-minute mark, now if people don't give me more numbers, I'm going to make it up. At the 10-minute mark, 1:23 in the fourth, and the quarters are 15 minutes. I'm not actually a huge sports ball guy. That's all right. You might be shocked to learn. Anyway, so let's say the touchdowns were at the 5-minute mark, the 10-minute mark, and the 46-minute mark. So if I want to access touchdowns 0 or touchdowns 1 or touchdowns 2, I can. But if I want to look at touchdowns -1, it gives me the last value. And as somebody said in the chat, indeed, we start from the end, or we work from right to left. So we can also work backwards through the list. But when I try to go too far backwards, well, now we get an error because there are only 3 elements, so you can't look at -4. So you can look at these elements as 0, 1, and 2, or you can look at them at, actually, sorry, from your perspective, 0, 1, and 2, or you can look at them as -1, -2, -3. So we can actually use negative indices in Python, which does mean things we just start counting from the back instead of counting from the front, but those range checks still apply. So let's look at some more examples. So let's think about if I want to list my names. So my full name is Jonathan Robert Anderson. Okay, there we go. Doctor is not part of my name. It is a title. And there are other honorifics that one can put before a name, and there are post-nominal letters like comma, Beng, Meng, Peng, PhD, those things. But that's not part of my name. My name is just Jonathan Robert Anderson. So what would the expression be here for my first name, given that I have a variable called names? There we go. So names 0. Someone said name square bracket 0, but not name 0. Names 0. And we have to be extremely, extremely picky, remember, because the Python interpreter is going to be really picky. Because it is a synthetic language, not a natural language. So we don't have any room for, oh yeah, but you knew what I meant. Because that allows ambiguous meanings. And in mathematics and in programming, we don't like ambiguity. We like precision. There we go. So names 0. Okay, good. So I could pull out my first name by looking at names 0. Given that names 0 as an expression represents my first name, how could I find the first letter of my first name? Think about that for a moment. Yeah, very, very good. So we've got in the chat, so we are allowed to take any expression that gives us an iterable, like in this case, names 0. I'm even going to put it in parentheses just for fun. If that's an expression that gives us an iterable, that evaluates as something iterable, well, we can take an index within that too. So we could look at, so let's do that another way. Let's say that, oops, first name is equal to names 0. So now we have a variable that holds just my first name. And so certainly we would be able to look at the first character in that name. However, we can just cut out the middleman. We can say, well, my first name is name 0, and then the first character within that is character 0. And so indeed, that gives us, excuse me, that gives us the first character of my first name. Okay, good. So there we go. That is what we're looking at here. And so now let's say I want to get my last name. How could it? There are at least two different ways. Well, there are two ways that we could do that using techniques that we've talked about today. How could I get... There's a lot of ways you could solve any problem in programming, but we've talked about two so far. So how could I access my last name? Right, so one of them would be names2. And yeah, okay, good. So, and as has been pointed out by a couple of different people, we could also use names -1. So what would be, so let's say, let's see, first name is equal to input first name, middle is equal to input middle name, last is equal to input last name, okay, and then names is equal to first, middle, last. Now, let's say that I wanted to write, so I want this script to tell me which room I should go to for the midterm exam, based on this. Based on these instructions. So what do I need to write in this little script so that the script will tell me which room to write my midterm in? I guess I should probably put away the code for just a second so you can see the rest of the page here. Yeah, okay, so good. So we want to either just use the last name, or let's start from names. So let's kind of ignore the stuff up there. Let's kind of ignore how we got the names. If I want to use names, I could say if names2 0, so get the name at index 2, and then get the character at index 0 from that name. If that, let's see, if that is between ordinal A and J, then print go to EN 2043. Otherwise, if the ordinal value is between K and S, go to EN 2040, else go to EN 4034. That should say go to 2040, not God to 2040. I don't think we'll find the Almighty in one room of the engineering building specifically. Okay, so all right, so here we can say, well, if names20 is less than or equal to J, if names20 is less than or equal to S, okay, very good. Let's say that, I'm just going to comment that code out for a second, and let's say that my names were Jonathan, Robert, Anderson. Okay. What is the problem here if somebody else wants to use this script? So lots of people could run this program, and let's say that it input all of their names and put all of their names in a list called names. And later on in the course, I will show you how we could actually do that in a way that doesn't rely on certain assumptions here. But let's say that we have all of your names, first name, last name, and however many middle names, all in a list. What's wrong with this script? Oh, someone says you don't have to get the ordinal value of names too. Ha! Yes, I do. Sorry. In fact, what I might do is, because I don't like to repeat myself, I don't like to write names20 and names20 multiple times. Let's do this. So let's save that in a variable, and then I just refer to the variable. So this is one example of a thing called refactoring, where if you find that you are writing the same expression multiple times, it can be a good idea to save that in a variable instead of writing the same expression multiple times, for a few reasons. One is programmers are lazy in a good way. We don't like to repeat ourselves, and related to that is the fact that if I'm typing the same expression 3, 4, 5 times, well, it'd be really easy to make a mistake and write almost the same expression 3 or 4 or 5 times, but have them be slightly different or something and not notice it. Whereas if I have that expression, the result of evaluating the expression saved in a variable, then I'm going to notice if it's wrong, because it's wrong everywhere. It's either right everywhere or wrong everywhere. If it's wrong everywhere, I'm more likely to notice. So that was an excellent point. Thank you very much for dropping that in. Yeah, okay, so there's no input function. That's true. Here I've said, let's assume this came from input. And later I'll show you how to take an arbitrary number of names and split them up into a list. But yes, so someone pointed out in the chat that different people have different numbers of names. So not everyone has a first name, a middle name, and a last name, right? Some people have multiple middle names. Some people don't have a middle name. Some people only have one name. It's not as common, but you know, there are people who only have one name. So if Bono was in this course, then, you know, what room would Bono sit his exam in? Now, I guess probably Bono has a legal name that might have more than one. Anyway, but there could be people who indeed have a legal name which is only one name. So this doesn't really work if I have someone who has 2 middle names or 3 middle names or 4 middle names. So how could we change this so that it would work with people who have different numbers of middle names? Right, so someone says last name is needed, so we should check the list with negative values. Indeed. So that is an excellent example of why we want to have negative indices. When first you see them, you might say, what? That's weird. Why in the world would I want a negative index? And the answer is, well, because sometimes we're interested in the last thing, or the second last thing, or the third last thing, and we don't really care how many things came before that. If I wanted to get the last name without using a negative index, how could I do that? There is a way. So how could I get the last name based on the length of the list, which might have 2, 3, 4, 5 different names in it? How would I get the last name? Right, so then we could ask, well, what is the length of the list? So I believe on Friday I mentioned that the length function can be used to tell you how many names we have. So in this case, that would return 3. So if I need to get names 2 when something is 3 elements long, or names 3 when something is 4 elements long, instead of writing names 2, I could write names, length of names, minus 1. And now we're starting to see where that negative value comes from. Because if I say, let's use an index of -1, that is the same as saying, take the length of the thing we're working with and subtract 1. So this is kind of a shorthand, a convenient shorthand for that. Okay, good. Questions about those things so far? Oh, and then I put in the slides. What's the last letter of your... Okay, yeah, no, that's a legit question still. I thought I just answered it, but no, I didn't. So what's the last letter of your last name? What would that expression be? Yeah, good. So, well, almost. Very close. So not name -1, but names -1. And remember, that level of precision might be annoying now, but it allows us to construct really cool things. So So it says, wouldn't length of names minus 1 not give the last name? Confused. Okay, okay, confused. Let's say that we have... All right, names is Jonathan Robert Anderson. So what is the length of names? Oh, okay, so yeah, it's the difference between the 0 and the negative. Right, so length of names would give us 3, so len of names minus 1, in this case, would give us 2, and names of 2 gives us Anderson. So I could also say len, so names, length of names minus 1 also gives us Anderson, and a shorter, more convenient way of writing that is simply to omit the length of names part. And this would also work for... Let's see. Okay, here. This is timely on account of new series launching soon. So if your names were, and I don't know what the J and R stand for, but J.R.R. and Tolkien, well, if you want to find out what is Mr. Tolkien's last name, well, it's names -1, Tolkien. So if J.R.R. Tolkien was writing this midterm exam tomorrow night, he would have to go to room 4034 in order to write his midterm exam. So to say hi to the cat for us. Hello, cat. Yeah. She's wandering around and she wants to go outside because it's fresh snow and it looks very nice out there. All right. Okay, so those are indices. And indexing within a list or a string or something else, and there are lots of data structures we're going to see that we can index within. Indexing within one of those things gives us a specific element, or allows us to access a specific element inside of a list. And there's other stuff we can do too. So let's say... Oh, sorry. Let me put Thani back up. So let's say that we learned that J.R.R. Tolkien's first name was John. I don't know if it is or not, but let's say it was John. After all, I think John is a very good name. So let's say we learned that. Then we could not just access the first element of names, or let's say it was, in fact, Jeremy. So when I write this assignment statement, you notice what's on the left-hand side. It's now, I'm not assigning to the whole names variable, but I'm just changing element 0 within that name. Oh my goodness, so people are so excited about the cat. This is fantastic, but I should note, by the way, so there were a bunch of things about cat, and then like a minute or two later, there were a bunch of things about cat. I'm wondering if people aren't live. So if you click live on the stream, it will catch you up. There we go. What's the cat's name? The cat's name is Persnickety. Oh, all right, go on then. Ugh. This is Persnickety, and she's a very nice cat. See? Hello. Oh, don't knock over my microphone. Oh, you want to say something to the people? Say something to the people. No? All right. There we go. All right, this interlude was brought to you by the letter P. So it says, show us kitty. This is a kind of a fun demand. All right. Okay, so what was I saying? I'm sure it was something useful. Right. If we learned that J.R.R. Tolkien's first name was in fact Jeremy, we could change that name by accessing element 0, and we can assign to element 0. And now, you see, when I look at the variable names, it is still a list. It is still a list that contains 4 elements, but now element 0 has changed. We have replaced just the first element, or just element 0, with Jeremy. Now, I don't think J.R.R. Tolkien's first name was actually Jeremy. I'm not sure what it was. Maybe somebody could Google that while we're doing this. But I'm going to change it back to J. And now look, when I look at the value of names, element 0 is just J. Oh, somebody is saying it was John. Okay, fantastic. So let's fill out Tolkien's name correctly. So names 0 is equal to John. Names 1 is equal to Ronald. names 2 is equal to Raoul, like the Phantom of the Opera. And we've already got the last name. There we go. So John Ronald Reuel Tolkien. Is everyone excited for this new series based on the Silmarillion and when Galadriel was young and full of pep? Yeah? Okay. All right, good. So we have, that is how we can access single elements within an iterable thing like a list. But sometimes we're interested in accessing parts of a list or parts of a string that are not just one element, but we're interested in accessing like a I'm not going to say subset because actually a set is a different data structure, but a sublist or a subsequence if we want to be picky and mathematical, which of course we do. If we want to be picky, then a subsequence of another sequence. So we can also, in Python, we can slice things, which means look at just a piece. So in this case, let's say that I define s here to be the sum of a bunch of values inside of x. So actually, let me ask you that question in Top Hat. Make sure everybody's still awake and paying attention even when there's no cat on screen. So here's a mathematical expression. 1 over pi times the summation. Answers are starting to trickle in ever so slowly. Okay, the answers now starting to come in a bit more quickly. I'm wondering, the delay characteristics seem a little bit different this time around. I wonder if there's if I'm getting slightly more latency from home rather than from the office. Well, hopefully we won't have to know for too much longer, because hopefully our next lecture I'll be back in the office. Oh, and by the way, I should mention, while answers are coming in, do take note. The next lecture will be on Friday. So because the midterm is an evening midterm, it is taking the place of a regular lecture. So I don't get to just have you for an extra hour in the evening and also carry on with regular lectures, because, well, you only have a certain number of hours in the week with which to do all of your courses. And so when I take an hour away from you in the evening, we give an hour back during the day. So we will not have a lecture on Wednesday. If people are interested, you could send me an email. I would be open to considering doing like maybe a tutorial session during that slot instead, maybe. Could possibly like record myself solving some of those problems, maybe. If you're interested, so like going through some of the midterm problems, if you're interested in that, send me an email, let me know. If a number of people, if like more than 10 people are interested in that, I might do that. If not, well, I have lots of other things I could do with an hour in the middle of the week too. So, all right, we have answers coming in, so I'm going to go ahead and close this. I'm going to count down and maybe tell me at what number you see this countdown stop, or you see the question close. So at 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and close. Oh, someone said, well, yeah, okay, 2. Oh, wow, fantastic. So latency is really good then. All right, 1 or 2 seconds. That's deadly. All right, so yeah, we had lots of answers here, and the correct answer was indeed, oh, we had a variety of answers actually. The correct answer was indeed 3. Because, now why in the world was that the correct answer? Well, some folks knew, and that was because, so S in this case was the summation from I going from 1 up to 3. And as we said, we're always counting from 0 in math and in programming. So this is x of 1 plus x of 2 plus x of 3 is pi over 2 plus pi plus 3 pi over 2. So 6 pi over 2 is 3 pi. Oh, hang on. I asked a different question in Top Hat from what I have on the slides. Okay, well, that could have caused some confusion because I meant to have in Top Hat the 1 over pi thing. Yeah, okay, that could have caused some confusion, so I will not dock anybody marks from this. I'll fix it so you don't lose any correctness marks. But yeah, so we had a summation in which we're adding up those 3 values inside of x of I. And in Top Hat, I said divide by pi. Oops. So in Python, we can do something kind of similar using a notation called slicing. So here I have... So names, if I want to access one specific name, I can refer to names 0, or names 1, or names 2. But if I want to refer to a range within that iterable, I can do something like names 0, 3. And that gives me more than one name. Or names 1, 3. Or names 2, 3. So what can you observe about what I'm typing here in Thonny and what it's telling you? Oh, interesting. Different people had different latency. So lots of people had like 1 and 2 seconds of latency, but a couple had like 4 and 5. Right, so what can you observe about what I'm typing here? So names 0 to 3 gives us 3 names. And it starts with John, and so we get John, Ronald, Raoul. Raoul? So what does that tell us? Or what can we infer, or as Sherlock Holmes might say, what can we deduce from this evidence? So we're taking a slice of the range, right? And when I say names 0 to 3, so it starts at name 0, does it go all the way up to name 3? So if I said names 1 to 3, well, then that gives us name 1, and it gives us name 2. If I say names 0 to 3, that gives us names 0, 1, and 2. Doesn't give us name 3 though, does it? Right. So the initial index is inclusive. So where we start is inclusive, and where we end is exclusive. Does that sound like anything else we've learned about recently? Does that sound familiar at all? Yeah, that sounds like a range, doesn't it? So if I had a range from 1 to 4, well, that's just a range object. But actually, I can turn that range into a list if I want to, using conversion, just like converting to an int or converting to a bool. And so we see that range from 1 to 4 is 1, 2, and 3. So the start is inclusive and the end is exclusive. You're going to notice that one thing we value highly in programming is consistency. Consistency allows us to look at this code, that code, and know that because they're following the same conventions, we can have a pretty good idea of what this code or that code is doing. Even if we're not deeply familiar with this particular function or something, we can still have a pretty good idea if it's conforming to the same sort of expectations, the same conventions as all this other code that involves things like iterables. Then we can reuse our assumptions about the way that it works, and we can also in many cases reuse other code. We can use, so without having to know how certain data structures work, if you know that it is something that is iterable and something that is indexable, okay, well, you know how indexing works, you know that it starts from 0, you know that it goes up to the length of the thing minus 1, you know that you can call the length function on it, you know that you can use slicing. All of these things that we have learned about with strings and lists also apply to lots of other stuff, and we can just use them and infer what they mean without having to learn about this new function or new data type in a whole lot of detail. So consistency is something that is really, really key. So starting at 0, starting with an inclusive end of a range and ending at an exclusive end of a range, that's something that's going to be really helpful. Also, another reason why this is nice is that if you start at the beginning and you put the length of something there, you get the right answer. It's actually index 0, 1, 2, and 3, but you get the right answer with the length of the thing there. So it's kind of, it helps not to get confused about, oh, do I have to subtract 1 at the end? Or so having an exclusive end helps with that kind of thing. So it is, right, so a slice is a slice of a list or a slice of a range or a slice of a string from the inclusive beginning to the exclusive end, and that works a lot like a range. And we can do other cool things with slices too, and this is something that this is stuff that's not going to be on the midterm tomorrow night, but could still be, it's still useful information. If you find a way to solve a problem more efficiently using this stuff than using the things that you learned up to the end of lecture 11, then feel free to fill your boots. I should also say, by the way, if you've done like Python programming before and you want to use some technique that we haven't learned about in this course in order to solve a problem on a midterm or even on the final or something, go right to town, fill your boots, no problem at all, as long as it's correct. If you give me a right answer, I'm not going to mark you wrong. So don't worry about, oh no, did I learn this elsewhere, or am I going beyond the course? That's okay. You don't need to know anything but what I'm telling you. So what I'm giving you in the lectures is all the material that you need to know. But if you know other stuff, then that's fine too. So and so we saw that slicing is kind of like a range. Well, it turns out that much like a range, we can also do things like specify an increment. So here, oh, and Ms. Hogan is saying that's kind of the same deal with the lab, that if you want to use additional extra stuff in the lab, go right to town. But you don't have to. You only need the stuff that we're teaching you. So similarly, I can actually, just like in a range, I can skip count. Well, I can do the same thing with slicing. So I could go from 0 to 4, skipping by 2s. So that gives me John and Rule. And in fact, we can even omit some of these elements. So if I just want to start from the beginning, I don't have to say element 0. If I want to go all the way to the end, I don't even have to specify the end. So names, : 2, or names, : 1, this is equivalent to writing this, names and then nothing, : nothing. That is equivalent to starting at the beginning and going to the end. So slices you can use in a slightly more advanced way, and even, this is kind of fun, we can even specify a negative increment if we want. So names, : -1, well, this is saying going from the beginning to the end, but -1, so going backwards. So names, : -1 would give us Tolkien's name in reverse. And okay, I have another question that I will assign to you as homework. So everybody do that question as homework after the lecture, and I will stop here for now. I won't go into well, actually, you know what I will do, I will tell you there are these neat functions called sorted, sum, and reversed. These are all built-in functions defined by Python. And actually, instead of me telling you what they do, I mean, the names are kind of clear for some of them. As an exercise for yourself, between now and the next lecture on Friday, you should run the online help function to figure out what those things do and try using them each at least once. So there you go. That'll be a nice little exercise for you folks. So that's it for what we're going to talk about today, and we're not going to have a lecture on Wednesday, but I am going to see each and every one of you in person, except for I think like one person who's already emailed me and they have a positive COVID test that is in play. So apart from that one individual, I think I'll be seeing each and every one of you tomorrow evening at 7 p.m. So really kind of looking forward to actually seeing you all. I mean, I've probably seen most of you in the lab at some point, but I'll actually see you all, so that'll be great. Okay, could today's Top-Hat question be open as assignment? Yes, absolutely. I try to do that automatically for all of them, but sometimes I forget a particular one or something. I say, I think I asked these 3, and I forget that I actually asked 4. If there are ever Top Hat questions that I've forgotten to open, don't hesitate to email me, and I'll sort it out. Okay, I see another question being typed. Nope, that question has gone away. So in that case, I guess that'll be it for now, and I will look forward to seeing you all tomorrow evening. Have a great day.